Okay, welcome back. Hopefully the incredible balloon demo actually worked for you. Some years it's amazing because the balloon that has a little bit of water in it can literally sit right on top of that candle flame for a couple minutes before it explodes and sprays everybody nearby with hot scalding water. So hopefully you understood the explanation that the balloon with water has a much higher heat capacity, so it takes a lot more energy to raise its temperature to the point where the balloon will pop. Air has very low specific heat capacity, so the air in the balloon and the balloon heat up very quickly with a small amount of energy and pop much quicker. If it didn't work for you, shoot, blame it on me because I wasn't there to organize and set it up. Okay, so now we're going to jump into the math, and some of you will like this. If you like math, this is the best part of enthalpy. And you are going to be doing some calculating. So hopefully you have a calculator. If not, bring one every day, and today you can use your phone instead. These first questions you don't need a calculator for. Okay, so what are we looking at? I'm going to be teaching all of this using units. So you need to know the symbols and you need to know the units. So Q is quantity of energy in joules or kilojoules. M is mass in grams or kilograms. C is the unusual unit, which is joules per gram degree Celsius or kilojoules per kilogram degree Celsius. And T is temperature degree Celsius. So if you can remember that, and there's a cheat, you can look up those units in your data book. I think like page 2 has a list of all the variables and their units as well. But you'll do enough of these, you'll remember them. Okay, so what are we looking for? Calculate the quantity of heat required. So the symbol, we start off with the symbol we're looking for is the quantity of heat. And the units we put next, kilojoules. So we want to solve for quantity of heat, Q, and the unit we're looking for is kilojoules. So I always write the symbol, and then I write the unit that I'm solving for. So that's the trick to these. Solve for kilojoules. We need to know what material is being heated or cooled. That's really important because every material has its own specific heat capacity. So ice has a specific heat capacity from that chart in your notes of 2.00 joules per gram degree Celsius. So that's our starting point. Every one of these questions, you can start with specific heat capacity because it has all three of the units in it. And we're always solving for one of those three units. So we're looking for joules, or in this case, kilojoules. So I'm going to take ice and I'm going to write its specific heat capacity, and I'm going to put the kilojoules on top and the kilogram degree Celsius on the bottom. Now remember, joules per gram is the same as kilojoules per kilogram degree Celsius. They're the same. The number doesn't change because what I've done is times the top by a kilo and then divided it by a kilo. And literally we could cancel those out and it's the same thing. So the size of the number does not go up or down by 1,000. Okay. So we're looking for kilojoules. Here's what we're looking for. I've put it in the right spot. All I need to do now is cancel out kilograms degrees Celsius and we have our answer. So 2 kilograms goes on top, so it cancels out with the kg on the bottom. Our difference in temperature goes from -4 to -2, so that's a difference of 2 degrees Celsius. We don't worry about putting a sign in there for gain or loss, just the difference, a difference of 2. Okay, do not reach for your calculator. Lucas, put the calculator down. Okay, same deal. Jaden, no calculator. Do it in your head. 2 times 2 times 2. Exactly. This is not hard. So that's 8. And sig digs is 1 sig dig from these guys. And our units are degrees Celsius cancel out. We're left with kilojoules. 8 kilojoules is the quantity of energy or heat required to warm 2 kilograms of ice 2 degrees Celsius. So that's how these work. Okay, let's try another one. Calculate the specific heat capacity of metal X. Okay, symbol is C. Metal X, specific heat capacity of X. So what units are we looking for? Specific heat capacity is the big unit. And I'm just looking ahead and I see kilojoules here and kilograms. So I'm going to put this one in kilojoules, kilograms. So there's the unit we're looking for specific heat capacity. So now I set up my problem and I put kilojoules on top. Where is it? There it is, 4 kilojoules. I put kilograms on the bottom and degrees Celsius on the bottom. Goes from 5 to 7, so the change is 2 degrees Celsius. Again, do not reach for your calculator. 4 kilojoules divided by 2 times 2 is 4. 4 divided by 4 is 1 kilojoule per kilogram degree Celsius, and we're done. Correct units, correct spot for the correct symbol, specific heat capacity of ice. Oh, not of ice, sorry, of metal X. That seems reasonable. Metals have pretty low specific heat capacities. Okay, third one. Determine the change in temperature. Okay, so the symbol we're looking for is delta T. Change temperature. The units for change in temperature are degrees Celsius. Okay. Units for this one, degrees Celsius, and it's ice. And remember, ice's specific heat capacity is 2.00 kilojoules per kilogram degrees Celsius. Kilojoules per kilogram. I don't know how that appeared in there. Okay. Now I'm looking for degrees Celsius. So that's the unit I want to put on top. Here it is. It's on the bottom. So we are going to flip this entire thing and we're going to put kilogram degrees Celsius on top and 2 kilojoules on the bottom. Now I have the unit I'm looking for on top. I want to cancel out the others. Let's flip our colors a little here. Okay, so how do I do this? I need degrees Celsius stays. I need to get rid of kilograms, so I need to put it on the bottom. That's times. So 3 kilograms on the bottom, and then those cancel. And I need to put my kilojoules on the top, 6 kilojoules, and then those cancel. And all I have left is degrees Celsius on top, which is what I'm looking for. 6 on top divided by 2 times 3, or 6 on the bottom, is 1 degree Celsius, 1 sig dig. So these were all designed just to do quick without a calculator. So now you have the basic patterns. We'll try some realistic questions. And these have more realistic numbers, and you do need a calculator for these. Okay. Sig dig rules, I'll go through them as we solve each question. And you must use correct sig digs. All right, here we go. Calculate the quantity of heat required. Quantity of heat required. And what's the substance? Water. Okay, so we need its specific heat capacity, which is right there. And this is interesting. They give us liters. And remember, 1 liter is the same as 1 kilogram. So that can become 3.25 kilograms of water. Okay, so because mass is in kilograms, I'm going to make my specific heat capacity kilojoules per kilogram degrees Celsius. Okay, calculate quantity of heat. So start with specific heat capacity because that has our units we're looking for. And we want quantity of heat or kilojoules. Whoops, I forgot to put my unit at the start. Sorry, we're looking for kilojoules. So I make sure kilojoules is on top. Okay, there it is. So now I can get rid of kilogram degrees Celsius. They're on the bottom, so I'm going to write them on the top to cancel them out. 3.25 kilograms. 99 minus 55 is 44. And this is addition subtraction rule for temperatures. So addition subtraction rule, you go with the least number of decimal places. And these both have 1 decimal place. So our answer has 1 decimal place. 44.0 degrees Celsius, 1 decimal place. Okay, so that's addition subtraction rule. And now for this whole thing, we're using the multiplication division rule, which is least sig digs in any measured number. So we've got 3, 3, and 3. So our final answer will have 3. So multiply those together, and you get 599.17. kilojoules. Everything else cancels out. Kilograms cancels out. Degrees Celsius cancels out. And we need to shrink this to 3 sig digs. 599 kilojoules. If you went to 600 even, it would be wrong. Don't round up. Stay with 3 sig digs. Okay. Carry your digits through in your raw calculation. So you're not rounding it into intermediate steps. Sig dig rule. Okay. Now, number 2, if you guys want, you could pause the video here and try this question on your own and then hit the play button and see how you did, or you can work through it as I work through it. Your choice, you guys decide as a class. Okay, I am going to start working on it now. Okay, calculate specific heat capacity of aluminium or aluminum. Specific heat capacity of aluminum. So I am going to be looking for, and I see kilojoules, kilograms, so we'll go kilojoules per kilogram degrees Celsius. Okay, plug them in. 23.30 kilojoules on top. And the other 2 units go on the bottom, 3.20 kilograms. And degrees Celsius also goes on the bottom, 63.12 minus 55.00. They both have 2 decimal places, so my final answer is 2 decimal places. 8.12 degrees Celsius. This is a lab report. Every number gets a unit. Okay, plug it into your calculator. All of the units remain, nothing cancels out, and you get 0.8967, 0.8967 kilojoules per kilogram degrees Celsius. Multiplication division, so it's 4 sig digs, 3 and 3, so our final answer is 3. 0.89, and the 6 rounds up to 7 kilojoules per kilogram degrees Celsius. Okay, and the last one. Determine the mass of iron. Mass of iron that was heated. So we're looking for this. I see kilojoules, so I'm going to solve for it in kilograms. Okay. So I don't have kilograms. All I have is kilojoules and degrees Celsius. Where do I get kilograms from? That is correct, Brooklyn. Specific heat capacity of iron. So I'm going to look it up in my data book. High technology. Yep, there it is under miscellaneous iron. And it is 0.449. So the specific heat capacity of iron is 0.449, and I'll use the kilojoules to match my units in the problem. Oh, and kilograms is on the bottom, so I got to flip this. Kilogram degrees Celsius over 0.449 kilojoules times. Okay, what am I doing here? I want kilograms. And I've got it, so I got to get rid of degrees Celsius, so I put it on the bottom. Oh, I got to do some math here. 163.12 degrees Celsius minus 22.50 degrees Celsius. What is that? 140.62? Yeah, 140.62 degrees Celsius. And it's 2 decimal places, 2 decimal places, 2 decimal. So now that introduces 5 sig digs for multiplication division and 3 there. And on the top goes the kilojoules, which is 3 sig digs. So our final answer is going to go with the lowest sig digs, or 3. 422 divided by those 2 multiplied together. And I don't have much space left. And the correct answer is 6.68 kilograms with 3 sig digs. I think in your notes it says grams, but I believe it's kilograms. Okay, yay. By the way, this is about where my video crashed the first time and I had to redo the entire thing because I hadn't done it in 2 parts. Oh, painful. Anyway, I'm done. Okay, so in your notes, you have at the bottom of your notes right there, thermal energy calculations, numbers 1 to 4. And then on the back, you also have, what have you got? 3, 6, 9 questions with answers. And I believe those answers all have the correct sig digs. So that should be enough practice for you. If you would like to do some additional questions, just because you love to be busy, these are optional textbook questions as well. And then tomorrow we continue on with more theory and examples and possibly another super exciting demo. Okay, have a good afternoon, everybody, and good luck working on your enthalpy.